This is an image of the night sky of the stars over Lake Huron, the lake that I grew up on. It was taken by scottrockphotography.com. Anyways, this is one of the reasons why I became a radio astronomer. You can see the northern lights in the distance. That's the low glow that you're seeing there. And in the night sky, you can see literally millions of stars, including the Milky Way. And as a little kid, I didn't care about the stars. I thought I knew what they were. I know what the sun is, so I figured I knew what they were. I was always interested in what was between the stars. And that's why I became a radio astronomer. And that's what this video is about. The GERA Foundation presents this series called Navigating Research. Now you can understand why I say I was born to be a radio astronomer. I wasn't interested in what the stars in the sky and all the pretty pictures that people looked at, and that was fine, it was cool. And I saw them as a kid, obviously, in the dark skies in Port Franks, in the middle of winter especially, but also in the summertime when the sun set very late, but you still saw the stars. But the simple answer is this, is that, you know, I wasn't interested in those things that I could see. I was always interested in those things I didn't understand and couldn't see. So of course I'd be drawn to what's between the stars. And it makes me a natural astronomer, a natural radio astronomer. And kind of interesting, I never thought of it at the time. I didn't know what radio astronomy was, never even heard of it when I was a child, no idea, no concept of any of that stuff. But I was probably drawn into something. You know, certainly it happened by accident. I went to university because I assumed I had to. I went into physics instead of math, which was an interesting choice. And then I absolutely wanted to do astronomy. And I wanted to do cosmology. I wanted to do theoretical astrophysics. And in the end, I got an option. I got given a graduate position either at Queen's University, work with the radio astronomer, Dr. Vic Hughes, or with a young researcher just graduated, and I would have been his first graduate student in Ottawa doing solid-state physics. And those are the two choices I really had. And of course I went for astronomy, and it was radio astronomy. So isn't that amazing? Again, you know, you talk about if you make decisions when you're young, and you keep looking towards them as you get older, every time you make decisions, you end up getting to where you want to get. So you can imagine, I made those decisions when I was quite young. I wanted to be an astronaut. I thought an astronaut was an astronomer, and I kept moving through my education and my understanding of where I should be, making decisions, and it got to being a radio astronomer. And that's what I did, and I worked at radio observatories all over the world, and I was fortunate to do so, because it's an absolute pleasure to be on a telescope. And anybody who's done radio astronomy will understand when you're standing up in the high steel, that feeling that you're connected to the stars you're listening to, and you're not really listening to because it's not sound waves, but the point is you could actually bring the sound coming out of the, you could put a speaker to your receiver and you can actually hear the sound of the stars. It's a crackling sound, nothing exciting. It's not like you're listening to some cool music or whatever. But for me, it was interesting. But to stand up in the high steel, I felt like I was absolutely connected to the stars. And radio astronomy, as I said, as a little kid, I looked between the stars, so it naturally led me to radio astronomy. And then I got a chance to do it. And I got a chance to be up amongst those big telescopes. And if you've ever seen a radio telescope, they really are quite large, because they have to be to get the sensitivity. Where, you know, optical, you can get a lot of it in a 5 or 6 or 10 meter mirror and things like that. Now they're going to 30 meters, which is very difficult for optical, but they're doing it, and they're going to get bigger still, don't worry. But in radio, you literally can have a 100-meter telescope and things like that, and some are larger, 500 meters. And it's just cool. They're just cool. And now you're looking between the stars, or you're looking what's around the stars, or you're looking what's around galaxies. But you're seeing a totally different image of the sky, the night sky or the day sky. You could do radio astronomy 24 hours. So as long as you're not looking directly at the sun, you could see most objects with the radio telescope, because our sun is relatively radio quiet compared to other more interesting sources. Anyways, so as a child, as I said, I actually started looking between the stars, and it made me a natural radio astronomer. Ain't that kind of entertaining? We know what the sun is, but I'm not going to tell you about it. I'll let the singers tell you, called They Might Be Giants.
Gigantic nuclear furnace where hydrogen is built into helium at a temperature of millions of degrees. Yo-ho, it's hot. The sun is not a place where we could live. But here on Earth there'd be no life without the light it gives. We need its light, we need its heat, we need its energy. Without the sun, without a doubt, there'd be no you and me. The sun is a mass of incandescent gas, a gigantic nuclear furnace where hydrogen is built into helium at a temperature of millions of degrees. The sun is hot. It is so hot that everything on it is a gas: iron, copper, aluminum, and many others. The sun is large. If the sun were hollow, 1,000,000 Earths could fit inside, and yet the sun is only a middle-sized star. The sun is far away, about 93 million miles away, and that's why it looks so small. And even when it's out of sight, the sun shines night and day. The sun gives heat, the sun gives light, the sunlight that we see. The sunlight comes from our own sun's atomic energy. Scientists have found that the sun is a huge atom-smashing machine. The heat and light of the sun come from the nuclear reactions of hydrogen, carbon, nitrogen, and helium. The sun is a mass of incandescent gas, a gigantic nuclear furnace where hydrogen is built into helium at a temperature of millions of degrees.
And now you can see how crazy people are. This is the electromagnetic spectrum. This is what all astronomers look at. And you can see in the middle, the optical astronomers, they look at visible light, and it's measured in nanometers. That's the wavelength at which the light coming to the Earth is. It's in nanometers when it arrives at the Earth. The radio astronomers, we're on the far left. We tend to look at the electromagnetic spectrum at wavelengths greater than a centimeter, effectively. There's some lower, some higher. And that is radio astronomy. And then you can see the other types of astronomy in here as well: X-rays, ultraviolet, infrared, millimeter. And each have their own Each have their own wavelength regime in which you operate in. And each require different techniques to do that. So the telescopes will look different, and they'll have different types of electronics and different types of technologies that are used so we can tease out information in each of these regimes. But as I said, radio astronomy is on the far right. This is the Whirlpool Galaxy. You can see it in radio, millimeter, infrared, visible, etc. It looks kind of similar in all of them, actually. There are other objects, I should have shown better examples, where they're completely different. There are objects can only be seen in the infrared or visible, and they're not seen in the radio. Our sun is radio quiet. It's very weak in the radio. Though we can measure it, we can look at it at very long wavelengths, like hertz and stuff like that. But, as a radio astronomer myself, I tend to look at objects that are star-forming regions. So they are only seen in the radio, in the infrared, and the millimeter, not in the visible typically. So, you choose your poison. This is the electromagnetic spectrum. Radio astronomers tend to look at radio waves that have wavelengths of the order of 1 centimeter or longer. This is a picture I took of Hartrail up on the hill. This Hartrail stands for Hardenbergstok Radio Astronomy Observatory in Gauteng province, South Africa, about 75 kilometers north of Pretoria. And this is my second love. My first love was an observatory in Canada called the Algonquin Radio Astronomy Observatory, and this was my second one. I worked on this telescope from 1991 through to 96, and then again in 98 for a bit of time, and a third stint I spent here between 2015 and 2018. And I still use this telescope to this day. This is a radio telescope. You can see in the foreground, the very front, there's a GPS station, and then there's a laser, a satellite laser tracking station is the white building in the middle, and then there's another telescope, a 15-meter off in the distance behind the 26-meter, which was the primary instrument built in 1960. This is where I did a lot of my learning in radio astronomy. This is where I learned to speak English even, to be honest. But this is where I love being, and out in these fields, absolutely amazing at lunchtime, going for walks there, and it was just an incredible experience working on this telescope. And when you're a radio astronomer, this is what you dream of. You dream of being at these places. Today, maybe people, they get excited about being at the universities and then going just to see it. No, for me, living and working at this place was a great pleasure. I enjoyed every minute of it. The sounds of that telescope, I could tell you what they were. If something went wrong, you could tell because it sounded different. And if you go to the very top of the telescope, this little spot up here, when it's at zenith, you're about 100 feet in the air, and you could stand up there and surf because the wind will catch the dish and it will vibrate slightly. And I used to love doing that. And I even had to chase monkeys off of the subreflector because they would damage wiring, etc. And I would run around there trying to chase the monkeys off. This is where I really became a radio astronomer. This is it. Harderbeespoort Radio Astronomy Observatory, South Africa. Absolutely loved it there. Love it to this day. And it's just an amazing instrument. It's 60-some years old now, 62 years old. Still operating. And that's what science is. That's what radio astronomy is. And this is a radio telescope. There are lots of different versions of these things, but this is what a radio telescope looks like. You have the mirror, the subreflector, the receivers are in here, and all the electronics and everything is in the buildings down below. So this is radio astronomy. The night sky or the day sky in radio astronomy is visible because radio waves go through the clouds. Now, depending on the frequency or radio wave you're working at, you'll see better in very clear skies. But you can still observe even when it's raining, to be perfectly honest, depending on the objects you're looking at and how bright they are. So you'll know there's an attenuation through the clouds, but radio astronomy can see night and day, and you can see the emission between the stars or the emission around stars or things like this. And so radio astronomy itself is just another band in the electromagnetic spectrum in which we can study the stars, the galaxies, and other interesting phenomena. Now, I do star formation. I study where stars are born. So they are actually really quite large clouds, maybe the size of our solar system and probably bigger. And there's gradual infalling gas making the central object, once it gets dense enough, it becomes a sun. And then it continues to get mass falling onto it, getting bigger and bigger, until it finally destroys the surrounding cloud and stops the process of mass growth. So that's what a star formation region looks like. Now, in those regions, there's lots of really cool radio astronomy phenomena you can measure. So you can look at, they have an ionized gas cloud around it, because as the star gets very hot, it eventually starts ionizing hydrogen molecules, and they just become a cloud of electrons. We call it an H2 region. That gives off radio waves that we can detect in these telescopes, these radio telescopes. So that's kind of cool. And then of course you have phenomena that are also in the gas clouds itself around this H2 region that they may look like, or they are, effectively lasers pointing at the Earth or pointing away from the Earth, but some are pointing towards us. And because it's radio waves, microwaves, we call them masers, M for microwave. And I study those particularly, especially if you want to do dynamical studies. It's much easier to look at very bright objects like masers. They're much brighter than the radio source. They can be tens to hundreds to thousands of Janskys, some millions of Janskys. So whereas the actual cloud, the H2 region will be, hundreds of Janskys and smaller, maybe micro Janskys. And masers will go for those whole ranges as well. But the brighter ones, because they're amplifying the radio emission in the background, if there's any variations in the background, you'll see it in the maser. So you could do time domain science studying how a star formation evolves. Anyways, that's radio astronomy in a nutshell. That's really what it is. Now, I'm not talking about the pulsars that people do. That's a spinning neutron star that gives a burst of radio emission towards the Earth every so many milliseconds or seconds. Or fast radio bursters, or extragalactic sources out of these giant jets coming out of the center of galaxies where there's lots of black holes that are causing all sorts of issues and energy pulsing outward. That's radio astronomy. It can be seen day or night. Whereas optical, you can't. You've got to look at night because the day sky is dominated by the sun and the diffusion of light through our atmosphere. So radio astronomy is 24 hours. So astronomers do it all day. That's a bad joke, sorry. And this is where we are. This is what radio astronomy is. So I became a radio astronomer largely because I was interested in what was between the stars as a little child. And it was part of that growth experience, that idea of, you decide what you want to be as a little kid. As I said, if you decide very early and you keep making decisions going towards your final goal, you tend to get to something. I didn't know anything about radio astronomy as a child. Nothing whatsoever. I was ignorant. But what I did know was I kind of understood what a star was. I didn't know what was between them. And I was really keenly interested to figure that part out. Made me a radio astronomer. That's why I went into radio astronomy in the end. And fortunate for me, I was able to. It was purely an accident, but that's what it is.
The GERA Foundation will produce more videos like this. Please like, share, or subscribe if you enjoyed this video.